Oh my goodness. In this video, we're going to be talking about recursion. Probably one of the hardest things for a beginner in coding to learn. And I'm being serious about that. Yes, this is one of the hardest things for a beginner in coding to learn. So let's go ahead and talk about recursion. What is recursion? Well, first off, we need to make a function. And let's call this function say hello. Alright, and this function has a parameter n. And usually n stands for a number, so you can already guess I'm going to input a number into n when I call the function. But let's go ahead and print hello. And let's go ahead and write down the string hello, and we print it down. Now, what is recursion? Well, there's a reason why I'm leaving space here, but recursion is when you call a function inside of a function. Yup, this makes literally no sense. You probably are wondering, how in the world does this even work? Well, if you were to just run this program right now, nothing would happen because we didn't call this function yet. But if we were to call this function, let's say you want to call it 7 times, let's go ahead and run say hello 7 times. What's actually going to happen is an error. Well, the reason why there's an error is because when we call this function, it runs the code inside of the say hello function, correct? Where we print hello, and then we call the say hello function again. Alright, well, if we call the say hello function, we run the code, we print hello, and we call the say hello function again. Right? So this call of the function inside of the function will run the function again. Here's the issue with this. It's going to go on infinitely. You can already tell that probably, but, well, if I scroll up, it's just going to keep saying hello, 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 right? And then we get an error at the end because in Python, I think it's 1,000 times by default. If you run a recursive function 1,000 times, then it just ends the program. It just assumes that you made a mistake with the recursion. Now, in order for this to actually end, in order for it not to run an infinite amount of times, like an infinite while loop, you need to set something called a base case. So we need to say if n is equal to 0, return in this case. And usually the base case is going to have a return. You're either going to return the number 1, or you're going to return nothing. It doesn't really matter. Well, in this case, it doesn't really matter. But in other cases, it will. But in this case, we're just going to return nothing. So when we run the program, notice how we print hello 1, 2, 3, 4, 5, 6, 7 times, just as we put into the input, n. Well, let's go ahead and take a look at what's going on here. When we put down 7 here, when we call the function 7, the first time we run this function, n is equal to 7, correct? So the first time we run the function, n is equal to 7. Now, is n equal to 0? It is not, so we do not return, and we just simply print hello. Next thing, we run the function again, but this time, n minus 1 is the new input of say hello. So say hello, the function say hello, has now n is equal to 6. Why is that? Well, on the first time we ran this function, n is equal to 7. Since n is equal to 7, n will be equal to 7 when we recall the variable, or when we call the recursive, the inner function. Right? And 7 minus 1 is 6. So the next time we call the function, n will be equal to 6. Is n equal to 0? No, it's not, so we print hello again. The next time we call the function, n will be equal to 6. And 6 minus 1 is 5. So the next time we call this function again, n is equal to 5. And as you can tell, it just keeps going down and down and down and down until n is equal to 0. And when n is equal to 0, you simply return, and the entire recursive chain ends. Right? So when n is equal to 0, we return. We do not print hello. Okay? We do not print hello. We just simply return. And then we exit out of every single recursive, whatever it's called. Recursive chain. Okay? So this is how recursion works. And this is a very simplistic example of recursion. Yes, there's a lot of thinking when it comes to this. And this is one of the things that you have to, well, write down in order to understand what's actually going on. Now, a introduction to a computer science course in your college or in your university, it will definitely cover recursion. Maybe at the end of it, maybe somewhere in the later half, but it's just simply it's just a difficult concept to grasp in your head if you want to just model everything in your head. You need practice, and you need to write it down to understand it. Now, let's actually decrease the amount of n to talk about the next point. Well, previously, we talked about how the numbers slowly decrease due to this n minus 1. Well, since they slowly decrease, your values of n will creep down to 3, 2, 1, and then down to 0. And then you'll return, and we simply print down hello 3 times. Now, what if we put down something after the recursive call? What if we print out something after the recursive call? What actually happens? Well, you might be wondering, how in the world will we ever run this print after, right? Because when you call the function, say hello, don't you just go all the way back to the top? You go all the way back to the top and you keep running the code down, 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 and then you call the function again, and you run from the top down again. You'll actually, seemingly, you'll never reach the print after. Well, if we run this code, we actually print after. Why is that? Well, here's the thing. When we call a function, say hello, technically we're just running the function inside of a function. So, for example, if we had another function, like def greeting, right? And nothing inside the greeting, the function greeting just simply printed greetings. Okay. If we run the function greeting inside of this guy right here, let's comment this out for now. If we run the function greeting, we're just going to print hello and then greetings. So when you call a function inside of a function, it still does the same thing as what the function that you called would do. Correct? Let's actually undo all of this. We don't need this greeting function anymore. When you call say hello, it does the same thing as this entire thing. It actually runs this entire code. But how does where does this coming? Where is this going? How do we print after here? Where does the after go? Well, when you run say hello and then you return, you actually exit out of this function call, and then after you exit out of this function, you can actually print after it. Okay? So when you run the code, when the computer is done running the code and say hello, eventually it's going to be finished with this line and it's going to move on to the next line. So you can kind of think of this as the greeting function. Say hello as the greeting function. Once you're done running this guy, you can move on to the next line. Okay? So eventually there's going to be an end to this recursive chain. Okay? There's going to be an end to it. And then when that end reaches, given by the base case, you actually return and you run nothing. You don't recall the recursive guy over here. And then when you're done running all the recursive chain over and over and over and over, you actually can exit out of this call of this function, just like the greeting function, right? When you run a function, after you run it, it's done. You can move on to the next couple lines. When you're done with the recursive call, you can actually print after. Now, let's go ahead and show you what's actually going on here by using comments. So if I were to show you what's actually going on, I can comment all this out, and I can kind of use logic here to explain this. So when you run the function, when you run a function, you actually just run all the code inside of it, correct? For example, that greeting function I showed previously, all it did was print. You can actually kind of just replace the function call with what it's doing, right? So when we call, let's say, when we say hello 3, n is equal to 3, right? So let's replace n with 3, and n is equal to 3 here as well. Therefore, the next time we call say hello, n will be equal to 2, correct? So let's write down a little comment here, 2. And then let's go ahead and let's write the comment 2 later. Let's go ahead and just simply copy and paste the code up here and then replace it with the say hello call. With the say hello right here, we actually realize that n is equal to 2 in this section. So right here to here is just when n is equal to 2. It was our previous say hello 2, right? And all we did was copy and paste the code and say hello. So when you copy and paste the code, now n is equal to 2 in this section, right? N was equal to 3 up here before, but now it's n is equal to 2 since n minus 1 is equal to 2. And then now since n is equal to 2 in this section, we can replace say hello, the n in say hello with 2. And then 2 minus 1 is equal to 1, right? Well, say hello 1 basically runs the code again, but this time n is equal to 1. So we can copy and paste the code again. But this time n just simply equals 1. When n is equal to 1, we can write down, and we can actually replace this n with 1. Now this time, when we call the function, say hello is equal to 0, or n is equal to 0 and say hello. So when we copy and paste the code again, this time setting n equal to 0, we actually realize that we return. So this entire section here was when n is equal to 0, correct? So when we call the function, n is equal to 0, so we actually technically just simply return. Okay, when we return, we actually exit out of this entire function. It's kind of just wiped off the existence of this earth. Everything after returning inside of a function does not get run, because when you return a function, it technically just kicks everything out. Okay, everything after the return call in the function just gets doesn't get run. It was just there in your computer. It just simply doesn't get run. Okay, so we can just remove all the code here after the return. And what we realize is that once we return, we have these print afters here. And this actually follows the proper order, does it not? When we do if n is equal to 0, hashtag 3, this is when n is equal to 3, we print hello. If n is equal to 0, and in this case n is equal to 2, we don't return, right? Since n is 2 is not equal to 0. So we print hello. If n is equal to 0, in this case n is equal to 1, do we return? No, we don't, since 1 is not equal to 0. Therefore, we can print hello. But in the case when n was equal to 0, we simply returned, and that's why we don't have to print hello here. And technically, since we returned, we don't recall the recursive function. We don't recall it. So since we don't recall it, this base case right here is where the function ends, and then we can print the afters. So as you can tell, all I did was copy and paste the code inside of the function, right? And just kept copying, pasting, copying, pasting, copying, paste it, while keeping in mind the variables that were associated with the base case. And then after I kept copying, pasting, and copying, pasting, and copying, pasting the code inside of the function, eventually you're going to hit the base case and you're going to return, and we simply don't copy and paste anymore. Since the function is no longer called, right? We do not copy and paste anymore. We simply return. We completely exit out of the recursive chain. And then we could run the code after. In this case, the code after was printing after. So this makes sense. Our output was hello, 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 and after, after, after. And we actually print hello, 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 after, after, after. So a good way to think about this is by just simply commenting something out and then copying and pasting it. Writing down the code is what's actually happening. Now again, still, I can understand if this is still confusing because you're taking advantage of something called a stack, right? So the structure, the data structure, the way that recursive functions work is by using a stack. You'll understand what that data structure means maybe I should cover that in my computer science playlist, right? Talking about specific data structures. But it's a little confusing, okay? And I get it. If you just keep looking at the code, if you just keep thinking about it, think about it when you're sleeping even. That's what I did when I was learning math and physics and coding. I would think about it in the bed because it's the quietest time of the day. But just think about it and try to grasp what's going on when you call the function again and again and again and have the code after it. So this right here is an example of what you can use recursion for with the Fibonacci sequence, right? So normally if you wanted to do something with the Fibonacci sequence without recursion, you'd probably have to take advantage of a for loop. You'd probably have to have way more code than just 1, 2, 3, 4 lines, right? And technically the function call, I won't even count it as a line of code. This is technically just 3 lines of code, okay? But here's the thing about this. It's incredibly difficult to understand, as I've said many times in this video. But basically what this function does is give you the numbers in the Fibonacci sequence. If you do not know what the Fibonacci sequence is, it basically is that the next number is determined by the sum of the previous 2 numbers. So in this case, 2 is determined by the sum of the 2 previous numbers, 1 and 1. 3 is determined by the sum of the 2 previous numbers, 2 and 1, right? 2 plus 1 is 3. 5 is determined by the sum of the previous 2 numbers, 3 and 2. 8 is determined by the sum of the 2 previous numbers, 5 and 3. And the rest of this chain, I guess you could just say it's 0, 0, 0, 0, 0, right? Anything in the past, I guess would just be 0, 0, 0, 0, 0. So basically what's going on here is if we print Fibonacci 1, what's going to happen is that we're going to get the third number in the chain. And that's because when we print out something, it's technically n plus 2. Okay, so if we write down 1 in here, we get the third number. If we write down 2 in here, we get the fourth number. Okay, so in this case, we write down 0, we simply just get 1. All right, and if we write down 5, we get the seventh number. So 1, 2, 3, 4, 5, 6, 7, 13. Right, this is the seventh number in the Fibonacci chain or the Fibonacci sequence, and we get 13. Right. What if we wanted to print out a larger number, maybe 9? And remember, 9 means that we get the 11th number in the Fibonacci sequence, since we have to n plus 2. And 89 is the 11th number in the Fibonacci sequence. So how does this function work? What's actually going on? Well, usually if you have some condition, right, if n or something like that, and you return after it, this is the base case. So this guy right here is what actually stops the function from working. Now, I can't entirely explain what's going on here with words alone. You simply need to just analyze this yourself. Maybe not. Maybe it's not simply. You need to work hard and analyze this yourself, because yes, I don't think I can explain with words. I genuinely think it's impossible for anybody to explain this with words, because there's just way too many things going on. Right? You will get confused if I use words. But this right is the base case. Basically, when n gets less than or equal to 0, you return 1. In this case, right? That makes sense, right? Because if you put n is equal to like -6, right? You should just get 1. Technically, you should get 0. I really don't know what the beginnings of the Fibonacci sequence are. I'm not a math theorist or study Fibonacci. But basically, if you write down, if n is just anything less than 0 or equal to 0, you just get 1, which makes sense. So let's go ahead and move back to 5. But basically, what this return does is it returns the sum of the previous number and the second to previous number, right? So Fibonacci gives you the number of a specific term. But if you want your next number, then you need to add the previous number and the second to previous number, right? n minus 2 and n minus 1. That's the previous number and the second previous number. And then you return that integer, and at the very end, when you return, you actually end up being able to print, right? So when you return an integer to a function, you can actually print that function, or maybe you can set a variable equal to Fibonacci. In this case, maybe we can write down like answer, and then write down Fibonacci, and then we can print out answer, right? And basically what returning does is just allow you to extract whatever value you return outside of the function when you call it. So in this case, return, when you call Fibonacci, technically this entire function is equal to 13. Okay, in the case of Fibonacci 5. Right, if you put n equals some different number, 8, the entire Fibonacci sequence, this entire function, which is equal to 55, answer is equal to 55, that means we can print 55. But basically, Fibonacci n minus 1 keeps running, it's like a double, it's a double recursive chain technically, because you're running recursion here, and then you're running recursion here too. But this right here just keeps finding the number before n minus 1, or before n, the number right before n, and then you can just keep going on down until you reach 1, and it just keeps adding the numbers and numbers and more and more and more and more until you can run this guy, and then it just keeps running that guy, running that guy, running that guy, running that guy, and then you get n minus 2. You add those two numbers up into the n, and then you can return the number so that you can access that value outside of the Fibonacci function. Just think about this, okay? This right here took me quite some time to understand. I'm not even going to lie to you as well. This took me quite some time. The last recursive function or example I would like to talk about is simply just the factorial function. So if we write down print factorial 3, we can run this code and we get 3 factorial, right? 3 times 2 times 1 is equal to 6. We can write down 5. 5 factorial is 120. And I'm not going to do any bigger numbers because my computer will probably crash. If I probably did 15, my computer would crash. It could run 7 fairly well, but yeah, I'm not going to go any past that. 7 factorial is equal to 50, 40, right? So how does this factorial function work? We have the base case over here. If n is equal to 0, then we simply return 1, which makes sense since the number that we multiply by at the very end of a factorial is 1, correct? 1 times 2 times 3, 1 times 2 times 4, 1 times 2 times 3 times 4 times 5, right? 1 is the first number when you're multiplying by a factorial. Now, me saying that, right, 1 is the first number that you multiply by factorial, isn't really explaining what's going on in the code. And I'm quite literally going to say this as bluntly as possible. I cannot explain it. Maybe some better teacher can, but I do not have the capabilities to explain recursion in a way that isn't very garbly and way too many things going on. Okay, but basically what happens is n times factorial n minus 1 basically gives you the final answer. So when you write down factorial 7 in the first case, n will be equal to 7. Therefore, this guy will be equal to 7. And factorial n minus 1 will be equal to 6, correct? Factorial 6, because 7 minus 1 is 6. And factorial 6 will do the same thing as what 7 just did, except it will just give us 6 factorial, right? So 6 factorial times 6 factorial times 7 factorial right here, or I guess it's technically 7 factorial times 6 factorial, right? Since n is equal to 7 in this case, and 6 factorial is equal to factorial n minus 1. This technically is equal to 7 factorial, right? Because 6 factorial, let's write this down if you guys don't understand factorials that well, but 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1, right? And this is equal to 7 factorial, since 7 factorial is equal to 7 times 6 times 5 times 4 times 1. All right. But basically what this does is it just keeps calling this factorial over and over and over again until we get, so technically it just keeps doing this, right? Keeps doing this, and then it keeps doing this again, and then basically keeps doing this and this, and then just so on, blah, 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 blah. Okay. But that's the basic logic of what's going on. I just highly suggest that you just look at the code and try to get what's going on. I gave you the examples that are probably the most helpful for beginner programmers learning recursion. Once you get the more complicated things, these won't be helpful. But they're good examples to learn from. But as always, if you have any questions, put it in the comment section. If you found this video helpful, consider subscribing and liking the video. Thanks for watching.